The Gulf Stream has shifted. Scientists have just made an alarming discovery, and this could be a warning sign of a major catastrophe for our planet. Today, we're taking a close look at what's coming our way and why we might be heading toward an ice age. Welcome, everyone.
What is behind the new discovery? Let's start from the beginning.
Deep in the Atlantic Ocean, a gigantic current system has been flowing for thousands of years. One that can best be imagined as a massive heating system for our planet. This system is called the AMOC, short for Atlantic Meridional Overturning Circulation. The Gulf Stream acts as the main pipeline of this system, pumping warm water from the tropics northward and thus providing Europe with pleasant, mild temperatures. Without it, Europe would easily be 10 degrees colder. The AMOC transports around 17 million cubic meters of water northward every second. That's roughly 100 times the volume of the Amazon River. This system is so powerful, so fundamental to our climate, that changes to it have global consequences, and it is precisely these changes that are the focus today. Because researchers at Utrecht University have now observed something that is causing them considerable concern. In a brand new study published in the journal Communications, Earth and Environment, René van Westen and Henk Dijkstra show that the Gulf Stream near Cape Hatteras on the North American East Coast has been drifting northward for decades. Cape Hatteras is located in North Carolina, roughly where the Gulf Stream breaks away from the American continental shelf and flows into the open ocean. A point of enormous significance for the entire system. At first glance, none of this sounds particularly dramatic, but it is. In their computer simulations, the scientists observed what eventually follows this creeping northward trend, an abrupt jump. Within just 2 years, the Gulf Stream shifted a full 219 kilometers northward in the simulation. And what is even more alarming is that this sudden jolt occurred several decades before the entire AMOC collapsed in the simulation. The Gulf Stream is thus in a sense a harbinger, like the canary in the coal mine, that is the first to notice when the air is running out.
Hey guys, quick request. YouTube is currently being flooded with hastily thrown together AI content, so-called AI slop. This isn't meant as general AI bashing, but it does make it harder for human creators to stay visible. This video here is not AI slop. It was researched, written, and produced by hand by several people who make their living from this. An editor, a video editor, a marketer, and myself. If content like this matters to you, your subscription helps us tremendously. Every subscription to the channel ensures that we can continue to put time and energy into real, carefully crafted videos. Thank you so much, everyone. And now, let's continue. Now you might be wondering, is this reality or just a computer simulation? Good question. And this is where it gets even more interesting because the researchers compared their model predictions with real satellite data.
And indeed, satellite measurements from 1993 to 2024 show a statistically significant northward trend of the Gulf Stream exactly at the point the model identified as critical. Additionally, underwater temperature measurements dating back as far as 1965 confirmed this trend. Two completely different measurement methods, one and the same result, that's what you call overwhelming evidence. But what is driving the Gulf Stream northward? To answer that, we need to dive briefly into the deep sea. Deep beneath the surface of the Atlantic lies a powerful countercurrent known as the deep western margin current. But this deep current flows in the opposite direction to the Gulf Stream, that is from north to south, and thereby exerts a kind of anchoring effect on the Gulf Stream, like an invisible hook holding the Gulf Stream in place. And if this deep current weakens, the hook loses its grip and the Gulf Stream drifts northward. And that is exactly what the data show. The deep western boundary current is weakening. The cause is believed to be the increasing weakening of the AMOC. This is because meltwater from the Greenland ice sheet flows into the North Atlantic, diluting the salty seawater, making it less dense and thus preventing it from sinking as effectively. And without this sinking, the Great Atlantic Circulation Pump can no longer function properly. Since 1950, it has already lost about 15% of its strength. That may not sound like much, but for a system of this magnitude, it is an enormous figure.
And what would happen if, as part of this development, the Gulf Stream drifts further north or the AMOC actually collapses? Ned Stark gives us the answer.
Winter is coming.
That wouldn't be a cozy winter vacation. Europe would cool dramatically.
Scientists expect a temperature drop of 3 to 10 degrees across large parts of Europe. Within a few decades, Norway, Scotland, Iceland, these regions would become inhospitable ice deserts, and temperatures would also drop in the rest of Europe. At the same time, sea levels along the east coast of North America would rise by up to 70 centimeters because the warm seawater is no longer transported away and accumulates. Coastal cities like New York or Miami would suffer from flooding. And that's not all. As a result of shifting climate zones, tropical rainforests would move southward, which would confront the Amazon with drastically altered precipitation patterns. In Asia, the summer monsoon, which feeds millions of people, would weaken.
In short, a runaway collapse is not a regional problem, but a global domino effect. The tricky thing about this domino effect is that at some point you no longer know which piece you should have left standing last. So do we all need to panic now? No, but we should be at least a little bit alarmed.
The study by the Utrecht researchers is so valuable because it shows for the first time how the Gulf Stream could be used as an early warning system. If it continues to move northward and then shifts abruptly, as simulated in the model, we know that the AMOC could collapse a few decades later. This potentially gives us a window of time to react, a window of opportunity that other proposed early warning indicators do not offer, because the Gulf Stream can be observed in real time via satellite. No decades-long measurement series are needed, no complicated deep-sea probes. Just look at it and check how far the current has shifted northward. It's just a shame that we've only had this systematic view of the current since 1993, barely more than 30 years, but the data from these years is already sufficient to identify a statistically significant trend, and that alone says a lot about how pronounced the shift has become.
By the way, this is where the difference lies compared to a disaster movie like The Day After Tomorrow, if you've seen it. In that film, everything freezes over within just a few days.
Reality is a bit slower, but no less serious for that. In fact, the process has been underway for decades, and the data clearly shows that we cannot stand idly by.
I'll keep you updated on further developments. So make sure to subscribe to the channel now so you don't miss anything, and don't forget to give a thumbs up so we can hit 5,000 likes. And since we're already on the topic of spectacular discoveries in inhospitable places,
in the next video, we dive beneath Antarctica. Deep beneath Antarctica, directly beneath the Russian Vostok station, scientists have discovered something that left them speechless. An ancient lake, completely cut off from the rest of the world for millions of years. A real, living time capsule that offers us insights into a forgotten world. To learn all about it and see the exciting original footage, be sure to click on the video displayed in the top right corner. As always, there's another video about science and space in the bottom right corner. Otherwise, I'd say see you in the next video. Take care, everyone.